For many centuries, the world was explained through the laws of Isaac Newton in classical physics. According to these laws, if the current state of an object is known, its future behavior can be predicted with relative ease. Chaos theory questions this deterministic vision. Not everything is predictable anymore, nor does it work like clockwork. Since the 1800s, mathematicians have raised the idea that not all phenomena could be predicted by Newtonian laws. But a meteorologist named Edward Lorenz made chaos theory a visible phenomenon. Lawrence deduced that this experiment was not a special case, that there were other systems in which tiny differences produced, over time, monumental changes, making everything seem unpredictable. That the flapping of a butterfly in Brazil could, in theory, cause enough of a disturbance to spark a tornado in Texas. Even though we have a good idea of how the universe works, there are no measurements that allow us to determine the exact position and speed of every atom in the universe. And this inaccuracy in our calculations makes predictions difficult. One of the reasons why long-term prediction is impossible. But chaos is not the same as disorder. Although chaos makes predictions difficult, the universe is not random, and effects still follow causes. And no matter how chaotic it may seem, a system always follows a trajectory towards a certain point. For example, in the calculations Lorentz used for his model, the trajectory created a pattern that resembled the wings of a butterfly. Understanding these patterns of chaos has practical applications. In the stock market, it reminds us that a slight fluctuation can cause a crisis in the market, and that is why we cannot speak of predictions, but of probabilities. And the human butterfly effect can be used to analyze social phenomena. For example, how trolling on social networks can be triggered by a single negative comment.